Hi, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. Specifically, in this clip, we're looking at our dynamic universe, and again, we're looking at equations and graphs connected to motion. So here we have a question that may appear in the exam, this type of question. And when you first see it, of course, your brain and eyes instantly look at all the graphs and charts and think, wow. But remain calm and read the question word for word. A swimmer dives under the water at an angle to the surface as shown. Okay. The graphs below show how her horizontal velocity component, v sub h, and her vertical component, v sub v, vary with time t along the x-axis before she surfaces for air. So we can see from the diagram she dives under, she's got a horizontal speed and a vertical speed, and then she pops up. What is her speed just as she surfaces? And then we have a selection of choices. So what's our approach? Well, again, we read the question closely and pick out the things we are being asked about. We are clearly being asked what her speed is, and we have some vertical and horizontal components to that. We'll look at the options to see if there's anything obvious we can ignore. Well, there is, I think, because we're being asked about her speed. We know that speed is a scalar, and that's positive, and we can see d is a negative option. So immediately I think we can just forget d, because speed is either 0 or positive. We know what part of the course this is from, so we can ignore the other parts. Read the question again in your brain, obviously, and avoid overcomplicating. If you're getting stressed or panicked, just stop, take a breath, maybe look at some of the formula sheets or the constants to see if anything prompts your thinking, and then try it again. So here we have the graphs that were shown. Now the question asks us about two components of velocity, horizontal and vertical, and asks us to find the speed. So this makes us think probably about vectors, one horizontal and one vertical. So we can place them end to end, but it also says just before she pops up for air. So we need to realize that when she does pop up for air, obviously both of her velocity components, horizontal and vertical, will be 0. So none of the options are 0, so that's not it. So it needs to be just before she pops up. And those are the points marked by the blue dot on the horizontal and the pink dot on the vertical. Those are the points we're interested in. So we know the horizontal component is 4 meters per second just before she pops up. So we can draw a line, a vector line that's with a value of 4 horizontally. And we can see that just before she pops up, she's traveling at 3 meters per second. So these two vectors end to end look like they form a right angle triangle. And that's great. We know we've crossed out D as an option because it's a negative. And now this is just a case of Pythagoras. So we have to find the value for the hypotenuse. Well, we know that the square of the hypotenuse from our formula sheet, if nothing else, is equal to the square, it's not equal to the square root at all. It is equal to the square of the horizontal component and the square of the vertical component. And that almost gives us our answer, because we just need to plug in 3 into the vertical component and 4 into the horizontal component and square them. And that will give us her speed, but obviously squared. So we need to do one more thing, which is find the square root of all of that, and that will give us her speed. So let's go do that. Here we have our triangle again, and here it is with the values plugged in. So we can see that it's 4 squared plus 3 squared, which gives us 16 plus 9 squared, which is 25. 16 plus 9, which is 25. And the square root of 25 comes out at 5 meters per second. So we have our answer. Our answer quite clearly is answer A. But we just need to make sure that we're also getting the right units, because in an exam question they can often change those units or miswrite them, so they might just be ms, meter seconds. That would be wrong. So just keep an eye on those units. But here the answer is A. Things to note: speeds. We're being asked about a speed that's 0 or positive, so we were able to eliminate D quite quickly. Try and picture the scene in your head as you read the question. Think about a swimmer diving under and what's going on. Then, because we could draw a triangle, think of Pythagoras or maybe trigonometry to solve this. You might have been given an angle in there rather than just the length of the sides. And here are some other examples to try. These are also available on my Hi page, hi.page/physics, FYSX, and you can find the answers there as well. So well done, that's another question successfully answered. Thanks for watching, and don't forget to subscribe.